Good afternoon and good morning, everyone. Thank you for joining us today. It's Tuesday with SOLIDWORKS. Every Tuesday, we are conducting a session along with our partner. And for example, last Tuesday, we have been conducting a motion analysis and how can we convert the result into static analysis. The main goal from this Tuesday series, Tuesday with SOLIDWORKS series, is actually to stay connected with you, listen from you, and provide you with more knowledge, more technical information. And today we will be speaking about the whole cycle. How can we connect the dots? So in the previous webinars, we started to speak about CAD, speak about CAM, speak about data management, simulation, but how can we connect the dots together from one stage to another? Or should we move in series stages until we produce our products, or can we use a parallel process using SOLIDWORKS solutions? And today's session, along with our partner, CAD-CAM-SIM. CAD-CAM-SIM is the engineering solution provider in the Middle East, mainly in Egypt, and we have been working with them since long time ago. And our presenter today, happy to welcome Ahmed Fouda on board, which is Senior Application Engineer. He will take us through the journey from a great design to great product. So the stage now is yours, Fouda. You get to go.
Okay. Hello, everyone, again. Thanks for your time and for joining us. Actually, there is a lot of information we want to present in our webinar today about design to manufacturing ecosystem inside SOLIDWORKS. So let's get started. You know that to create a great product, you need design tools that are flexible enough to support creative thinking, yet powerful to enough handle the complexity of today's products, and that provide manufacturing what they need to develop the finished product. The traditional process we currently have to make a product is a serious process, from generating a new idea, making conceptual design, define the project, make the MCAD and ECAD, then validate that design and prepare it for manufacturing, and finally document this design and assure his quality. Using that traditional process create a lot of challenges, and in today's competitive market, with the need to produce products faster with higher and more predictable quality at lower costs, companies are looking to streamline their workflows. Providing all the tools in a single environment eliminates the time-consuming need for data to be translated between departments, which often results in errors and intelligence gaps. As we see, with SOLIDWORKS design to manufacturing solution, concept to final assembly work can now happen concurrently in one seamlessly integrated and managed system. Let's see how can we do that. First, let me ask you, what is your current process to make a new product? Is it a manual process or an automatic process?
So, gentlemen, we are expecting some contribution from your side. Please hit your answer. And there is a small trick. Let me remind you with that. You might need to minimize the window, go to the window mode, not maximize the window, to be able to participate in the poll. Okay. Very good. So more to come. Let's close the poll and share the results. So as you can see, Fouda, most of our audience today, they are making manual process. They do have manual process to make the products. So
okay,
let's continue.
So yeah, so let's continue. And you know that coming up with new ideas is really crucial these days. So let's see how SOLIDWORKS support users to improve innovation. So ideas is not one team decision. It takes all the effort from multiple teams. Market surveys and sales contribution to define what's the next step. Either it's a totally new product or an enhancement to an existing one. And at some point, we need to set the focus on the projects we agreed to initiate, and who is responsible for each idea. And the second step is to follow your own success formula. Each company has a secret recipe of innovation, which can be used over and over to make successful products. So innovation is not, as some people might think, is a chaotic process. No, actually, it's a systematic formula that if you follow will lead to great innovation. But with a single point of truth, everybody in the organization with very little training can contribute to this formula, even the newcomers that traditionally you will spend many hours of seniors' time to train and keep on the right track. So once you define this formula, you can define your projects, and as we said, one platform for everybody, not only engineering, but even sales and marketing with their expectations of market price and expected sales quota. A motivation for everyone in the team to contribute to company growth. So as we saw, SOLIDWORKS Manage will give you the chance to do the process and item management in one place. This will help you standardize the innovation cycle, and finally, you will have centralized data instead of multiple data silos. The next phase is conceptual design. And innovative conceptual design is the core of any successful product. That's why you should have the right tool for that. Let's see how we can use SOLIDWORKS to create your concept design. Simply start a sketch on either a plane or face using AutoShape. Your capture pen or finger strokes are initially converted to geometric shapes. As you sketch on a screen, relations to surrounding geometry can be automatically inferred as you go, enabling instant capture of design intent. With a sketch now complete, a simple extrude used in combination with the contour select tool is all that's required. So whether you are designing complex shapes or simple mechanical parts, touch sketching in SOLIDWORKS offers a completely new approach to capture rapid-fire design ideas, whether you are in the office or on the go. Actually, being able to define a project elements and all its milestones is a crucial step for any business cycle. So projects also act as a container to pull together all supporting and related information. Gantt charts can be created by templates that have key stages and milestones for your MPI process already defined. And once created, timelines can be easily modified with simple drag and drop. Assigned resources and tasks are visible in the same area. SolidWorks Manage, again, provide critical information to help teams focus on important tasks and provide an overview of resource capacity for better planning and utilization. Manage project stages, timelines, and milestones along with resource utilization and capacity. Utilize user tasks and timesheets to automatically track progress. And again, let me ask you, are you making any physical prototypes for your products? Please answer with yes or no.
So let me remind you, gentlemen, that maybe during the session you can ask your question. If you do have any question, there is a question box over there that you can throw over your question there, and we will do our best to answer your questions. Okay, so thank you for participating in the poll. Let's share the results. So yeah, so let's say 50-50. Some of them, they are making physical products, and others are not. Okay.
Okay, and despite of that, we know that the need for virtual prototyping is increasing as companies struggle to competitively differentiate their products and beat competitors to market. Quick decisions within engineering have become increasingly critical. Cutting what-if scenarios from the equation helps you make better engineering choices to ultimately bring your best products to life. And topology study is a new design guidance study type that adds small technology to the simplicity of a typical simulation setup. Loads and fixtures are added as usual, followed by user-defined goals and constraints to drive the calculation. In this example, we look for the best stiffness to weight ratio. Additionally, you can use manufacturing controls like wall thickness or symmetry, and here we use preserved regions to maintain enough material for the bearings. The more tools give results more suitable for traditional manufacturing processes like casting or machining. We use stamping for machinable results. Topology study use an additive solver rather than weight. Results actually in the topology study include a plot showing material safety, remove, or you can add for a smooth mesh. A great starting point for additive manufacturing and mesh results can be saved directly to new configuration or new part. And also, a stress calculation based on the mesh result is also available, giving you even greater confidence in the recommended topology. Using SolidWorks simulation, you will be able to make a virtual prototyping for your products by applying real-life scenarios to predict the product performance in action. Even in the most challenging studies, SolidWorks simulation keep assisting design engineers with the ease of use and rich library of materials. After we finish the phase of virtual prototyping, we come to the main stage of the design life cycle, which is making the detailed mechanical and electrical design. And SolidWorks provide different tools and capabilities to support designers and engineers at this phase. So let's see some of it. We may break down the detailed design phase to 4 sections. First one, that will be showing how can we focus on the design itself and not the tool. The second one covers all the industry-specific features available at SolidWorks. Third one is for how we evaluate the performance of the designs we make. And the final one will cover the tools available to check the manufacturability of our designs. So let's start with the first one, how we focus on our design and not the tool. You know that all great designs start with a great idea, and sketching in SolidWorks is simple and straightforward. Even the most complex ideas are easy to realize with instant feedback and standard tools. And the standard tools that always at your fingertips, and essential features such as holes are easily created using that hole wizard feature, and the extensive library of hole types and configurations is also available at your fingertips, keeping your design consistent with company standards. Actually, rapid design changes can get you ahead of the game when it comes to competition. So SolidWorks enables you not only to modify design dimensions, but also drag and drop geometry. And SolidWorks also handle even the most complex shapes. Take sheet metal part design, for example. Walls, hems, and forms are created with usual constant workflow the SolidWorks user love. Standard features can be dragged from a design library, and meanwhile, SolidWorks keeps the flat pattern up to date. And actually, also the design of structures is whatever it's complex and challenging. You have dedicated tools and workflows, and SolidWorks lets you define your members for industry standards. And for assemblies, also SolidWorks cares of the complex assemblies containing many thousands of parts, and addition of hardware such as nuts, bolts, and washers is also easy. This automatically resized based on standards to fit the application. And every time you don't have to create design from scratch, as you have the ability to use your legacy data. And this takes us to the 3D Interconnect. 3D Interconnect continues to allow you leverage 3D design data from whatever source you like without compromising on capability. It supports neutral file formats, like IGES and STEP files. Now these files can simply inserted into your SolidWorks assemblies and used like other component. This will allow you to do more with existing files from other 3D design tools, eliminating the need for time-consuming migration of data. And the next phase is for actually electrical engineers. And electrical engineers now can work in parallel to generate detailed electrical schematics and define the complete electrical system. They can take advantage of automated design tools and built-in libraries to streamline and simplify an array of traditionally tedious tasks. And also, mechanical designs can integrate the electrical system into the 3D design. moving to the next section about industry-specific features. So let's see what we have in this one. Actually, SOLIDWORKS has long been an industry leader in the modeling of welded frames and their components. That structure system feature is an advanced weldment environment that lets you create and modify structure members of different profiles. And workflow makes it easier to create complex systems with flexible corner management and trimming. Actually, the structure system comprises primary and secondary structure members. You can build primary members on a grid you create using 2D and 3D sketches, segments, points, edges, reference planes, even surfaces. And secondary members can run between two primary members. You define a secondary members by selecting a support plane and two primary members, or by clicking two primary members. And when you finish defining the structure members, the software opens the corner management property manager. So you can fine-tune the corner treatments, and for sure corners update automatically when you make changes to the structure system or member profiles. Also, one great thing SOLIDWORKS has a time-saving library of smart parts and supplier standard components, and it's fully integrated with SOLIDWORKS. So you can benefit of different options inside SOLIDWORKS as toolbox, 3D content central, and finally the 3D experience marketplace parts bar. And there are some tools that are optimized for the creation of plastic parts, specifically features as snap hook, mounting boss, and lip and groove. This kind of features help the designers to make plastic part design in a fast and accurate way. Actually, SOLIDWORKS 3D CAD allows product designers and mold makers to easily amend their design at any stage, from development to manufacture. With fully integrated modeling software suitable for plastic, cast, stamping, formed, and forged designs, product design, mold design, and validation in one package. With molds and drawings generated from the original 3D model, SOLIDWORKS associativity guarantees your solid model is always accurately reflected within your mold, and even NC data without the need to track and edit files individually. Actually, the way SOLIDWORKS helps you move through the design cycle smarted with fully integrated drawing. Your team can create drawings directly from the 3D models, ensuring accuracy and preserving correspondence. So you can create 2D drawings of the 3D solid parts and assemblies you design. Part assemblies and drawings are linked documents. Any changes that you make to the part or assembly, a change in the drawing document. Generally, a drawing consists of several views generated from the model, and few views also be created from existing views. For example, a section view is created from an existing drawing view. And drawing in SOLIDWORKS is just like drawing in 2D programs, but by integrating the drawing process with 3D modeling, you save time both creating and correcting your designs. And with SOLIDWORKS in your team, link drawings and models ensure consistency, so you can design products smarter. And moving from 2D to the 3D, SOLIDWORKS MBD or SOLIDWORKS model-based definition. SOLIDWORKS MBD allows you to create 3D drawings and to define, organize, and publish manufacturing specifications directly in the 3D parts and assemblies. And this will help you eliminate and streamline manufacturing. You can create 3D dimensions and tolerances and capture 3D views similar to a drawing, including different orientations, zoom factors, configurations, and display states. So with SOLIDWORKS, you can publish 3D PDF files that are easily read, and you can pan and zoom and rotate your model just like in SOLIDWORKS. So you will able to quickly switch between explode and detail views, and even cross-highlight between 3D model and its bill of material table. Also, SOLIDWORKS, as an industry-specific feature, SOLIDWORKS offers a capability to design piping, tubing, and harness. So you can generate and document system, including harness, pipe, and tube paths, pipe spools, pipe slope, and a complete bill of material for the entire system. Actually, this will help you shorten the development process and reduce time to market by designing harness, piping, and tubing in 3D system design. And with these capabilities integrated in the design process, designers are able to ensure efficient assembly, operation, and serviceability without rework that delays and add additional costs. And now for the next section, and it will be about evaluating design's performance. So we know that manufacturing companies across all industries have made 3D virtual simulation a valuable engineering tool to trace and define their physical products. Sophisticated simulation is no longer just for specialists. It's the inspiration that fuels innovation. So product engineers can make their technical decisions driven by simulation insights, uncovering significant product and business benefits. And with powerful and intuitive simulation solutions, product engineers can virtually test new ideas quickly and efficiently, evaluate performance and improve quality, and get the knowledge for product innovation. So SOLIDWORKS simulation is an easy-to-use portfolio of structural analysis tools that use finite element analysis to predict a product's real-world physical behavior by virtually testing CAD models. The portfolio provides linear and non-linear, static and dynamic analysis capabilities. And SOLIDWORKS flow simulation is also an intuitive computational fluid dynamics solution embedded within SOLIDWORKS 3D CAD that enables you to quickly and easily simulate liquid and gas flows through and around your designs to calculate product performance and capabilities. And SOLIDWORKS electronic cooling module that includes both analysis productivity, capability, and enhanced simulation functionality. It gives designers and engineers a great tool set to tackle the tough challenges of electronic packaging of PCBs and electronic components. The electronic cooling module enables designers and engineers to quickly and accurately model complex electronic systems for thermal analysis. With its combination of ease of use and industry-specific tools, the electronic cooling module ensures maximum analysis productivity with enhanced simulation fidelity. And we come to the final section that about how we can check the manufacturability of our designs. Design for manufacturing, or as we call it, DFM, is a systematic approach to optimize manufacturing that focuses on the time and difficulty to complete steps within the manufacturing process. SOLIDWORKS actually has many tools to check design manufacturability, and one of them is what we use to check moldability of our designs. Tools such as draft check, undercut check, and thickness check. Another DFM tool is SOLIDWORKS costing. SOLIDWORKS costing is now used by designers, manufacturers, and coating departments to automatically estimate manufacturing costs directly from 3D models. And manufacturing operations are automatically recognized, and the cost of each part can be rolled up for total cost of your assembly. SOLIDWORKS cost helps engineers, designers make real-time design decisions based on cost, and also helps executives and managers to keep product cost on budget, and enables manufacturing personnel to instantly code 3D parts and also assemblies. So SOLIDWORKS 3D CAD and SOLIDWORKS simulation tools enable companies to dramatically improve the way they develop and manufacture products, as it provides easy to learn yet extremely powerful functionalities that shorten product development time, reduces costs, and improve quality. So what about electronic design inside of SOLIDWORKS? Let's see how we can do it with SOLIDWORKS. We have SOLIDWORKS PCB, and SOLIDWORKS PCB provides electrical engineers with a unified environment between schematic and board layout tools. The power of Ultium is packaged in a delightful SOLIDWORKS-inspired user interface. As we see, one button, push or pull connection to SOLIDWORKS 3D CAD. And the integration between SOLIDWORKS 3D CAD and SOLIDWORKS PCB helps us work faster and reduce errors. We no longer have to export and translate models between disconnected software apps. Our mechanical team can now finalize mounting locations, check for enclosure clearance, and run a thermal analysis to make sure we have adequate cooling of the board. SOLIDWORKS PCB enables the productivity you need to design printed circuit boards quickly, along with unique collaboration between electrical and mechanical design teams. So at this stage, let me ask you another question. Have you been requested to produce rendered photos for your products before? Please answer with yes or no.
Okay, so can we wait for a couple of seconds? Maybe other audience would like to participate. Okay, so let's close the poll and share the results. Okay, it's almost the same results. Okay, so most of the audience, let's say, some of the audience today, they have been requested to produce some rendered photos.
Okay, so at this stage in our design cycle, I think we need to quickly and easily create professional photo quality images or animations or other interactive 3D content to get our products to market faster. So we have here for presentation SOLIDWORKS Visualize, and SOLIDWORKS Visualize is a camera for your CAD data and helps you leverage your design work to create photographically to visualization directly from your CAD model, utilizing the industry most powerful ray tracing engine, and painting your model with accurate materials is also easy inside of SOLIDWORKS Visualize. SOLIDWORKS Visualize real-time photo accurate results virtually eliminates guesswork, giving your customers a deeper emotional connection with your design. Exploring different aspects of your product's persona is simple with SOLIDWORKS Visualize, as it's capable of telling a deeper story that resonates with your end users and key stakeholders. So SOLIDWORKS Visualize has the power to bring great designs to life and combine your audience attention all from the convenience of your CAD data. One of the most important steps is technical documentation, yet it consumes actually a lot of time. So let's see how SOLIDWORKS overcomes this challenge. We have SOLIDWORKS Composer. SOLIDWORKS Composer is the tool for creating high-quality assembly instructions, product manuals, and any type of technical communication. You can access the data directly from your original CAD design. And SOLIDWORKS Composer high-quality graphics are easier to understand than any photograph. And for design changed updates also are practically automatic. So with SOLIDWORKS Composer, you will be able to create instructions faster than you ever thought possible. And it also will be more intuitive as it reduces cost of assembly line mistakes. And best of all of you can start creating assembly instructions as soon as the design is created inside of SOLIDWORKS. The final stage before releasing to manufacturing is the quality assurance. So it's really critical phase. We have here SOLIDWORKS inspection, and in SOLIDWORKS inspection, first article inspection reports can be generated from dimensions and annotations that have been applied directly to the model geometry. Use them expert and SOLIDWORKS MBD. And now new projects can be defined with just a few simple clicks. First, you choose your templates, and SOLIDWORKS inspection instantly recognize and extract critical information for your model, such as custom properties, dimensions, and annotations. Next, you choose the type of 3D annotation you want to be ballooned, and then in a matter of seconds, inspection will go ahead and balloon and extract all of the key information required. Selecting an annotation in the characteristics tree displays its inspection information and highlights the related item on the model, making navigation quick and easy. And once all the model information has been captured, you can automatically generate a first article inspection report using a variety of industry standards. So with using SOLIDWORKS inspection, first article inspection reports can be created in minutes instead of hours by eliminating the need to create 2D inspection drawing. And finally, the last phase is preparing your designs for manufacturing. We have here SOLIDWORKS CAM. SOLIDWORKS CAM delivers fully integrated knowledge-based CNC programming right inside of SOLIDWORKS. SOLIDWORKS CAM generates machining information fast using automatic feature recognition, standard operations, and strategies defined with your own best practices, including step over, cut depth, tool type, and size are instantly applied to the model, freeing up your time to focus on critical areas of the part. And using SOLIDWORKS CAM, powerful simulation capabilities, cut path can be reviewed and compared against the original model. So using SOLIDWORKS CAM delivers powerful knowledge-based CNC programming for part and assembly, milling, and turning that provides a single integrated solution from design to manufacture. And I think we have come to an end of our solution, and this manufacturing ecosystem of products, it actually allows companies to go from concept design to manufactured parts faster than ever before. And actually, thousands of companies have been taking advantage of this manufacturing ecosystem for years, and as a result, have become leaders in their respective markets. So again, I think we have come to an end of our webinar today about SOLIDWORKS design to manufacturing ecosystem, and it was a pleasure for me to having you at this webinar. So
thank you so much, Fouda. Thank you for this very informative session. A key word here that we need to say that to go from idea to great product it's one word: integration. So try to pick all of your solutions as integrated as possible. And of course, the